All animals and plants are made of cells, and cells need to give out and take in certain chemicals in order to function. Let's see how this happens. First, diffusion. Diffusion occurs when gas particles spread out. Diffusion also happens when particles dissolved in solution spread out. Here is a drop of ink. It has a high concentration of inkiness. When we drop ink into water, the inky particles spread out. They move from where there's a lot of ink, a high concentration, to where there is less, a low concentration. They move from a high to low concentration, so we say they diffuse down a concentration gradient. The greater the difference between the high and low levels, the faster the spread. When you burn toast, the smell gets round the house because of diffusion. Smoke particles move from the toaster, a high concentration of smoke, to the rest of the house, which generally you'd hope have a low concentration of smokiness. Well, I scraped most of the burnt bits off, and here's the toast going round my gut. Food gets turned into the chemical products of digestion, amino acids, sugars, etc. The concentration of these chemicals in the gut is high, but in the nearby blood capillaries it is low. They're desperate for digested toast. Result: the particles move from the gut to the blood by diffusion. Diffusion or wily cunning? No, right, diffusion. Take a deep breath in. Where does the oxygen in the air go? Well, firstly, into the alveolar airspace in the lungs. But where we need it is in the blood. You can breathe out now. How does the oxygen reach the blood circulating through the lungs? It diffuses from a high concentration of oxygen in the airspace across a thin membrane and into the blood, where there is a low concentration of oxygen. Without this mechanism, you wouldn't last the time it takes for me to explain all this. The thing to remember is that diffusion is movement from high to low concentration, and the greater the concentration gradient, the faster this takes place. Okay, I think you've sussed that. Let's look at the other mechanism for moving stuff around. That's called osmosis. For this, we're going to need a partially permeable membrane and two solutions with different concentrations. Before you dash off to get them, you've got loads already in every cell in your body. Each cell wall is a partially permeable membrane. Sounds attractive. But what is it? It's a barrier that lets some substances through, but not others. In osmosis, the chemical they let through is water. If we put pure water on one side of the membrane and a chemical solution on the other, then you know what's going to happen. The water will diffuse from high to low concentration of water. It goes from the pure water side, which is a high concentration of water, to the other side, where there is a lower concentration of water. This puts water into the chemical solution side, making it more dilute. Works every time. All the while, a small amount of water is flowing back the other way, due to random movement of molecules. But most movement is from pure water in the solution, making it weaker. Eventually, the concentrations on both sides of the membrane are the same. Then, there is an equal flow of water in both directions. We have reached equilibrium. Oh, that's better. Now, take a look at my sister's spider plant. Not looking too good, is it? If she'd remembered to water it, then it'd look like this. Water gets into plant root cells by osmosis, and then up into the rest of the plant by more osmosis. This makes the plant's tissues stiff, so they can hold up the leaves. So that's about it. Remember, diffusion takes particles from an area of high concentration to one of low concentration, as in the burnt toast incident. And osmosis takes water through a partially permeable membrane, from a weak solution of dissolved solute to a more concentrated solution, as in plant roots, so long as someone waters them in the first place, obviously.